Most of this chapter, though, is going to be about some simple equations. If the volume goes down, but none of the gas gets out, what happens to the pressure inside? It goes up. If the volume goes down, the pressure is going to go up inside. Have you ever tried to take a balloon and just squeeze it between your hands? And as you squeeze it, you're making the balloon smaller. What happens as you squeeze it, though, to the pressure? It increases. It's just the only reason you can't just keep squeezing it right down, right? Because eventually the pressure gets too great and you can't squeeze it anymore. If we get a chance, I'll do a demonstration using the vacuum. I'll suck out all the gas out of this scenario, but we'll come back and do that one if we get a chance. But here's the equation we're going to use. This is called Boyles Law. P1V1 equals P2V2. It's an inverse relationship. So if the pressure goes up, the volume goes down. Or if the volume goes up, the pressure goes down. And a lot of this chapter is going to be like this example, word problems. And the key to success in word problems, until you get really good at them, is writing down, what am I given? What do those things mean? Where should I put them? So in this word problem, we have Freon at 56 torr, and its pressure's changed to 150 torr. Temperature's constant, so I don't need to worry about the temperature because it's not changing. So what does 56 torr represent? Is it a volume or a pressure? Does torr measure volume or does torr measure pressure? It measures pressure. 1.5 liters. Is that the starting volume or the final volume? That's the starting volume. Yeah, 1.5 liter sample at 56 torr. So the V1 and the P1, the 1 means this is the starting temperature or starting pressure or the starting volume at the beginning. The 150 torr is the final pressure, and we don't know what the volume is. One of the things I want you to think about is, how could I take this equation and rearrange it so that it was volume 2 equals what? How would I solve it in terms of volume 2? Mathematically or algebraically, what has to happen to P1V1 equals P2V2 so it's just volume equals the rest? Move the P over. And since this is being multiplied here, we'd have to divide it. Exactly. We're going to divide it over. So P1V1 over P2. And then we're going to plug these values in. Just plug them in. P1 and V1 and P2 would equal our volume. What are you expecting to happen to the volume? Should it go up? Should it go down? The pressure is increasing, so what should happen to the volume? It should decrease. And it's always good to kind of use that logic to evaluate your answer before you get it. I have a volume of 0.56 liters. So it did decrease. It did decrease by about a third. It decreased by a third because the pressure tripled. If the pressure tripled, then the volume should go down by a third. This is Boyles Law. Yes, sir. Right. Means no one's heating it up. It's not gaining any temperature or losing any temperature. Maybe you're just squeezing the balloon. Or
I thought like if you increase the pressure, the temperature goes up. Or
if you change the volume, the temperature can change unless the pressure changes also. So a lot of times what we're going to talk about is cylinders, maybe like a piston in your car. And you have a cylinder and that piston can move up and down. So the volume could be changed inside the cylinder because the piston's moving up and down. But the temperature might not. It's just the gases are closer together or the gases are farther apart as the volume changes. So maybe the temperature's a constant though.